All right, so here is your molarity review. So the molarity equation, we use that when we're trying to figure out how to make a certain solution. So molarity equation is moles of solute over liters of solution. And when you're working with this, you're going to need that, but then many times you're also going to need to be able to go between grams and moles. And again, to do that, we use molar mass. So you will need your periodic table. All right, so let's put these into practice. All right, so what is the molarity? All right, so it's asking me for the molarity of a solution in which 125 grams of NaOH is dissolved in enough water to make 0.800 liters of solution. So again, I think it's always a good idea to start with the molarity equation. Molarity is moles over liters, and then I'm going to put in what I know. All right, I don't know the molarity, so this is what I'm trying to find. I do know, however, that I have 0.800 liters of solution, but I do not know the number of moles. All right, so, and again, we've got molarity is that capital M, so this is what I'm solving for. And to find the number of moles, what I need to do is I'm going to use this 125 grams of NaOH. All right, so hopefully at this point, converting grams to moles is somewhere, almost to the point where it's in your DNA. You're like, okay, grams. I know if I'm dealing with grams, I need the mass from the periodic table. And that's always going to be equivalent to 1 mole of NaOH. So if I find these things in the periodic table, I've got 22.99 plus 16 plus 1.01. So I end up with 40 as my gram number down there. So I've got 40.00. Those 00s are important. Again, your calculator does not think in number of decimal places you should have on a number. So if you just leave that off, you've just totally changed the number of significant figures. So don't do that. All right, so then I just need to take 125 divided by 40 to get my moles. So I've got 3.13 moles if I round for sig figs there. All right, and then I'm going to take that number and put that here. All right, and then I can solve that. So 3.13 divided by 0.8, and I actually just left the 3.125 in my calculator. So there might be a little bit of variation in my answer versus yours, but that's what we check. We always check for those. So 3.91 moles per liter, or you can answer it as 3.91 molar as the capital M. Either one's going to work. All right, let's try another one. All right, this one, now we're looking for the mass of Na2SO4. So I'm going to end with a gram number required to prepare 0.250 liters of 0.175 molar. Again, molarity is moles over liters. So I know my molarity value is 0.175. And that capital M tells me that it's on that side. That is equal to some number of moles over 0.250 liters. All right, so right away I can solve this. And again, you can think about whenever we've got that equal sign in there, think about that as cross multiplication. So for every 0.175 moles for every 1 liter, I'm trying to figure out, well, if I only have 0.25 liters, how many moles do I have? So I can just cross multiply 0.175 times 0.250. And then these mole numbers tend to be pretty small. So 0.043, and I only got 3 sig figs to work with, so I'm going to make this an 8. That is moles, and again, that's moles of Na2SO4. All right, but the question asks for mass. So again, going from moles to grams should be something that is pretty intuitive now. For every 1 mole of Na2SO4, you get your periodic table mass of Na2SO4. And I don't have a periodic table with me. And do I know all of those? I feel like sulfur is 32.06 or 07, but I don't want to mess it up. So that's what you would do to get your answer. And again, you'd want to have 3 sig figs on your answer. And that is how you do these types of calculations. Hope that helps.